For this project, we decided to investigate how a Venturi flume impacts the flow rate of a system. For a little background, the Venturi effect is a phenomenon in fluid mechanics that refers to the reduction in fluid pressure occurring when a fluid flows through a constricted channel such as a section of a pipe. This was first described by Italian physicist Giovanni Battista Venturi in the 18th century, and it's a direct consequence of the Bernoulli equation. The Venturi effect is demonstrated in various applications such as spray bottles for fine misting, vacuum cleaners for suction generation, and wind tunnels to simulate high-speed airflow for testing. One way to show the Venturi effect is through a Venturi Flume, which is a device that takes advantage of the Venturi effect to measure the flow rate of a liquid based on changes in an elevated section that causes pressure to drop. To measure flow rate, we need a measured pressure at an early point during the flow and at the constriction point. Having these pressures allows us to use key equations, which allows us to calculate the fluid velocity and flow rate at the point of constriction.
Moving into the weir. A weir is a small barrier that impedes the flow and increases the flow rate. They've been used for a long time for irrigation and water management. The math ends up being the same for both the weir and the flume, with the only difference coming from the change in height, where the water height at the end is much lower for the weir. Looking at the CADs, our goal was to provide a very strong visual demonstration, which is why we ended up choosing the weir flume combination because it had the best visuals.
Hey, my name is Grayson. We've got Will behind the camera. These are a few different versions of our project here. We really had to incorporate a bunch of different details together to try to get them to work. Probably about 17 different versions total. These are the versions that almost worked, but the ones that you really care about are right here. We've got our two final versions of our flume, which was our initial goal, and our weir. The flume is the best of all of the previous flumes and incorporates a line so that you can really see the dip. I'll play that video for you. And then the weir actually utilizes a flume to facilitate the flow and show you how it works.
Go. Good. Finally, the weir performed as expected with a smaller exit height and a faster flow rate. For future projects, we would like to test with a bigger exit valve and a device that gives constant flow rate to minimize errors.